everyone, in this video we're going to determine some short time, speed, and distance calculations. This is very similar to the time, speed, and distance calculations that we have already learned. The biggest difference here is that we are going to use a different index rather than the 60 index. We will be using the 36 index. What this does is it converts the B scale, so a reminder of the scales, the outer scale is the A scale. The B scale here previously represented minutes. When we use the 36 index, this B scale now represents seconds, and the C scale represents minutes when using the 36 index. So you may be wondering why we would use this particular method versus the traditional time, speed, and distance method using the 60 index. This method, the short method, is useful if the time is less than 1 minute or the distance is less than 1 mile. The short method will produce somewhat more precise calculations. You can use the short method for standard calculations, so that would be times greater than 1 minute or distances greater than 1 mile, but keep in mind that the B scale will again represent seconds and the C scale will represent minutes when using this method. In the first example, we have a known speed, a known ground speed of 130 knots and a known distance of 0.5 miles. So if we're on a flight, for example, we may already know our ground speed, we know the distance between 2 points, the distance between A and B, and we are trying to determine the time between those points. So again, in this example, our speed is 130 knots, so we will use the number 13 on the A scale to represent 130. The distance is 0.5 miles. So the distance will be also on the A scale. Remember, there is that reminder right here on the face of the E6B. So the distance is 0.5. We will use the number 50 to represent 0.5 based on the concept of the floating decimal. So according to the instructions on the E6B, we need to set our rate index to align with the speed on the A scale. So instead of using the 60 index, which we used in the traditional short time and distance problems, traditional time, speed, and distance problems, we will use the second index, or the 36 index, which is right here. You can see there's a small arrow with the name seconds next to it. So we will align our E6B so that seconds arrow, the 36 index, aligns with 13, which represents 130 knots. Our distance was 0.5 miles, so again we will use the number 50 on the A scale to represent 0.5, and our time to travel 0.5 miles at 130 knots is on the B scale in seconds. Remember, the B scale is now in seconds. So we have an answer of 14 seconds to travel 0.5 miles at 130 knots. In the next example, we have a known speed of 155 knots, and we know the time it took to travel between points A and points B, so that would be 36 seconds. So we are trying to determine the distance between those points. So we will align our 36 index, or seconds index, with our speed of 155. So right about there, we have our seconds, or 36 index, aligned with 155. We can now find the time, which was 36 seconds, which just so happens to be in the same place as our arrow right here, 36. And above that on the A scale will be our distance. So that's about 1.55 miles. In the next example, We know our distance and we know our time, so we are trying to determine a ground speed. This will be a ground speed check. This is something that you will have to demonstrate in the aircraft during your check ride. So we have a distance of 0.8 miles and we timed 22 seconds between our 2 points. So we'll find our distance of 0.8 on the A scale. We will use the number 80 to represent 0.8, and we will find 22 seconds on the B scale, which we could just use the number 22 to represent that. So now we have alignment with our time of 22 seconds and our distance of 0.8 miles. If we find the 36 index, the seconds index on the E6B, which is right here, we can look above that on the A scale to determine our ground speed, which is 132 knots. In our last example, we have a speed of 230 knots, so we're moving pretty fast, and a distance of 3.2 miles. We are trying to determine how much time it will take to travel that distance at 230 knots. We have assumed that that time will be less than 1 minute, which is why we are using the short method rather than the traditional time, speed, and distance method. So again, we can align our 36 index with our speed of 230. That would be on the A scale. So we'll use the number 23 on the A scale, align that with our seconds index, our 36 index right here. Those are now aligned. And we have a distance of 3.2 miles. So the distance is on the outer scale. We're looking for the number 32. So this would be right here. That would represent 3.2. And right below that will be our time in seconds on the B scale, so it's about 50 seconds. So don't get too confused with this method. It's really no different than the traditional time, speed, and distance method. And remember, the face of the E6B has instructions to make these calculations. Once again, we can find those right here. So those instructions still apply for the short method. However, instead of using the 60 index as your arrow, which we would use for the traditional problems, you will use the 36 index as your arrow. So this arrow right here would represent this 36 index arrow for the short time, speed, and distance problems. Again, as I said earlier, you can also use the short method to determine longer distances, so distances greater than 1 mile or times greater than 1 minute. The short method will still work, except that your C scale will represent minutes and your B scale will represent seconds. So for example, if we had a speed of 165 knots, we could align our seconds index with 165, which we have right here, and a distance of, let's say, 8.3 miles. So we could find that distance on the A scale. So we'll use the number 83 to represent 8.3, so that would be right here. And we can look on the C scale to determine the amount of time it will take in minutes. So that shows approximately 3 minutes to travel 8.3 miles at 165 knots.